Hello everyone, this is Ojo Emmanuel and you are welcome to the JILBOTIcs Classroom. So in this tutorial we will be talking about resistors. Okay, so what is a resistor? As the name already defines it. So it simply means a material that resists something. So resistor is an electrical component, so it resists something. So what is that? Okay, you know what it means to resist something, that is to hinder something, to try to reduce the effect of something. Okay, so now it resists something. What is a resistor resisting? Yeah, so what is a resistor resisting? Okay, resistor is resisting the flow of current. Okay, you know current, right? From your Ohm's law, V is equal to IR. So a resistor resists the flow of current. Now you might ask a very important question, that why is a resistor resisting the flow of current? Is current not meant to be flowing normally like that? But a resistor is needed because every electrical component has the maximum amount of current it can take for it to be in a good working condition. You know what I mean by that? So now once you exceed that current, it is different for different components. Okay, so now once you exceed that current, your component might get damaged. Okay, so you need a resistor to resist the flow of current, and it reduces the flow of current to keep your component in a good working condition. We are going to look at an example as we proceed. Okay, so now remember in our previous tutorial I said you shouldn't try connecting your LED directly to the power source, that is your 5 volts on the Arduino. So now remember I promised to explain why you shouldn't do that in the next tutorial. So here we are. Okay, so now you know why you shouldn't connect it directly. So the current coming out from your 5 volts is too much for your LED. It's too much. It's more than what your LED can take. Okay, so now since it is more than what your LED can take, if you pass that current directly through your LED, it may damage your precious LED, and you don't want to do that. Okay, so now what is the solution? You add a resistor to it. So now we are going to look how you can do that. Okay, but before we get to that, let me explain some basic things. The resistance is what a resistor offers to the flow of current, so we call it resistance. So now when we are talking about the physical quantity, we call it resistance. So the resistance of a resistor. Okay, and resistance is measured in ohms. You can see the symbol there. It's measured in ohms. Okay. So now, okay, I remember I said you shouldn't connect your LED directly, that you need a resistor to reduce the flow of current to keep your LED in a good working condition. Now you might want to ask, how do I know the value of resistance that I'm going to use? It's very simple. Okay, so now, but before we get to that, I'm going to explain the two types of resistors that we have: the variable and the fixed resistor. As the name implies, the variable resistor changes resistance as you apply physical effort or an external factor to it. Okay, so for instance, your LDR, light dependent resistor, is a variable resistor. As the amount of light falling on it changes, the resistance changes. Okay, but a fixed resistor on the other hand has only one value. It has a fixed value, so it cannot change. So in the case of our LED, we are going to be using a fixed resistor since we know the amount of current we want to flow through it. Okay, yeah. So now you can see the symbols of a fixed resistor and a variable resistor. Okay, you can see it there. So now, how do you choose the right resistor for your LED? It's simple. Okay, so now remember we are using our 5 volts from our Arduino as the power source for this demonstration. Remember 5 volts. Okay, so now let's get to business. How do I know the maximum current my LED can take? Okay, so now it's on the internet. You can check on the particular LED you are using. The LED you have in your kit is a 5mm LED, and I think the value of current is uniform for most LEDs. You can check it online. Okay, but for the LED you have in your kit, you need about 18 milliampere for it to work perfectly. Between 18 and 20 milliampere for it to work perfectly without damaging it. Okay, so now recall Ohm's law. V is equal to IR. But remember, we are looking for the resistance. So just make R subject of formula. So R is equal to V divided by I. Remember, we are using 5 volts from the Arduino. Okay, and our I is 18 milliampere. Milli is times 10 raised by 3, so you convert it to ampere. And when we divide it, we get 277.78 ohms. So that is the amount of resistance you need. Okay, and you can use this approach for other components, provided that you know the voltage and the current. Okay, and that's it. Thank you for watching this video. If you have any question on this particular tutorial, you can ask on the platform provided by JILBOTIcs. And I remain Ojo Emmanuel, and bye for now.